Today, we are looking at the last lesson in Unit 6. We are talking about improper integrals. Students will integrate functions over an indefinite integral. Sometimes we are interested in integrating over an indefinite integral between negative infinity and positive infinity. But how on earth do you do that? Although the interval and the area extend indefinitely, the total area is finite. And that takes some serious convincing of yourself to do. That even though, here's an example that we can figure out later. This one is e to the negative x. So if I integrate between 0 and infinity, and it's not true for all functions that go to infinity, just certain functions, you might be able to actually find the area, even though this extends forever and ever and ever. The area is finite. I know some of you aren't going to like that very much. But there's three types that we have to deal with. Negative infinity to a value to positive infinity, or negative infinity to infinity. So let's look at example 1. Consider a region under y equals 1 over x squared and to the right of x equals 1. So we are going to look at a picture here. 1 over x squared actually looks like this. It's in the first and second quadrants. Between 1 and it's just to the right of 1, so it's over here to infinity. So you are going to set up an integral between 1 and infinity of 1 over x squared dx. Because you have that infinity in there, it's an improper integral. So right below in my definition, I'm going to sneak ahead a little bit. If I integrate between 0 and infinity, infinity is not actually a number, it's more of an idea. So we have to write this as an integral. So this is the limit and an integral. The limit as, we'll say t, because that's what the u's below, goes to infinity from 1 to t of 1 over x squared dx. So this would be the limit as t approaches infinity. 1 over x squared, I can't integrate it the way that it's written, but I can bring that to the top, x to the negative 2 dx between 1 and t. We add 1 to that exponent, which is negative 1, divide by negative 1 between 1 and t. So this is the limit as t approaches infinity of negative 1 over t. I'm going to bring this back down to the bottom. And the negative can float to the top or bottom, minus a negative 1 over 1. So infinity, and for t, this becomes negative 1 over infinity plus 1. Well, what's a number over infinity? A number over infinity is 0. 0 plus 1 is 1. So even though we're finding the area between 1 and infinity, this has a finite area of 1. I know that's crazy, very crazy. So there's my definition. 0 to infinity of f of x dx is the same thing as the limit as t approaches infinity from a to t of f of x dx. If the limit exists, the interval converges to a real number. This is a word that you're going to be very tired of when you get to unit 10. The interval converges to a real number. So if it has an answer, we say that it converges. If the limit does not exist, we say that it diverges. That's kind of the new word for us. Does not exist means diverges. Also infinity, if you got infinity for an answer, infinity does not exist, infinity diverges. So example 2, determine if this integral converges. So write it as a limit problem. The limit as t approaches negative infinity, t to negative 1 of dx over x. If we integrate dx over x, we've done this one enough by now, we know that that's natural log. The natural log of the absolute value of x between t and negative 1. So now we're going to put those values in. The limit as t approaches negative infinity, natural log, the absolute value of negative 1 minus the natural log of t. So natural log of the absolute value of negative 1, that's 0 because it's the natural log of 1, which is 0, minus the natural log of negative infinity. So Well, let's make this a t. Well, no, I guess if it's infinity, we'll put the infinity at the end. So this is negative natural log of infinity. So here's our natural log curve. If x approaches infinity, what does y approach? Infinity, but very, very slowly. So this answer is actually negative infinity, but negative infinity does not exist. We say diverges. Diverges. Example 3, determine if the integral from 0 to infinity x e to the negative x converges. If so, find the value. Now, that infinity, I know it's a definite integral, but your calculator is not going to help you out here. Oh, the first thing I would look at is u substitution. I'd say that u is negative x, and I would say that du is negative 1 dx. So this kind of looks like it would be e to the u. I could put in a negative du, but now I have this extra x hanging out in the front, and that's not going to work. I could replace it up here with a u because they're the same thing. So this one isn't u substitution, but what would this be? We just learned about this recently. Integration by parts. Yep, integration by parts. So I have an algebraic term. I have an exponential term. So if I do LIATE, I got my algebraic, I've got my exponential. So u is equal to x, dv is e to the negative x dx. The derivative of u, or the derivative of x, would be 1 dx. The integral of dv is e to the negative x, but that's going to be balanced out with a negative in the front. So this becomes uv minus the integral of v du. And the limit as t approaches infinity of 0 to t. I know we got a lot going on here. This would be the limit as t approaches infinity. U is x, v is negative e to the negative x, minus the integral from 0 to t. V is negative e to the negative x, and du is dx. I should have written smaller apparently. So this becomes the limit as t approaches infinity, x, like this. I'm going to make this plus the integral from 0 to t of e to the negative x dx, and we still have to integrate this. This would be e to the negative x with a negative in the front, negative x e to the negative x between lost my integral, 0 and t, goodness. And this is still limit as t approaches infinity. So this becomes negative t e to the negative t minus e to the negative t minus negative 0 e to the 0 minus e to the 0. All right. So e to the negative t, I'm going to factor out a negative. This becomes t plus 1. This term would be 0, this first term, but this one's going to be a 1. This is actually plus 1. All right. Oh my goodness. We're still dealing with the limit as t approaches infinity. So this is negative e to the negative infinity. This is infinity plus 1 plus 1. E to the negative infinity, this is 0. Infinity plus 1 plus 1. So as we continue on with this problem, 0 in the beginning plus 1 means that our answer is 1. Good job. Discontinuities, when one or both endpoints is undefined or we cross over an asymptote somewhere in the interval. This is where we could have a discontinuity. So when you look at number 4, it actually doesn't look too bad. You're like, okay, I've got a 1 minus x squared. Maybe you know what that is. It's on the golden ticket, but this would be inverse sine. The 0 is actually just fine. Your issue here is the 1. Because if you put 1 in place of x, 1 squared is 1 and 1 minus 1 is 0, you're actually dividing by 0, which doesn't work, so it's not part of the domain. So we need to write this as a limit problem. The limit as t approaches 1 from 0 to t of dx over the square root of 1 minus x squared. So this piece inside we already said is inverse sine. So it's the limit as t approaches 1 of inverse sine of x between 0 and t. So this is the limit as t approaches 1, inverse sine of t minus inverse sine of 0. So inverse sine of 0, think to your unit circle. Where is the sine value equal to 0? And your sine value is the y value. So this is 1, 0. And this is 0, 1. So I would say that this is 0. Minus from the inverse sine of infinity. Well, no, not infinity. Look, I just made a mistake. I was all infinity happy. That should be 1, right? There's my 1. So inverse sine of 1. Well, where does inverse sine of 1 happen? It happens up here at pi over 2. This is pi over 2 minus 0, which is pi over 2. Ta-da! Theorems that can be used to determine convergence or divergence. Again, when we get to unit 10, we are going to be experts at this, but there are 2 of them. One of them is called the p-test. I know that sounds kind of funny, but if we integrate between 1 and infinity, and p is this exponent down here in the denominator, if p is greater than 1, it will converge to this value. And if p is less than or equal to 1, it will diverge. If I integrate between 0 and 1, they kind of flip-flop. If p is less than 1, it converges. And if p is greater than or equal to 1, then it diverges. It diverges. So let me give you a quick example of that. 1 to infinity, 1 over x squared dx. I feel like we have that already. Because I have this 2 here for the p, that 2 is greater than 1, which is up here, I would say that it converges. And the exact value would be 1 over 2 minus 1, which would be 1. And if I look up here, didn't we already do that problem? Oh, I guess we did 1 over x. No, I did it here. The very first thing, I got a 1. So these are a little bit weird. We've got this infinity in here. Be patient with yourself. Be very patient with yourself. Take your time. All of the integral rules that you've learned up until this point are still valid. So use substitution, anything on the golden ticket, partial fraction decomposition, integration by parts, substituting trig. I mean, this is heavy. The hard part is deciding which rule to use, not necessarily how do I use each rule, but which rule do I use? So keep at it, folks. I know this is tough. Unit 7 coming up is one of my favorites where we get to find area and volume. So get through this with me. Unit 7 will be just around the corner.